So, just to try to orient you to what we're looking at, this is geometry. Here it says semester 2. This says number 1 trigonometry. That's the first unit we're in, is trigonometry. And then this is lesson number 4, and the title of the 4th lesson is Cosine, Hypotenuse, and Inverse Practice. Right? So when you're matching this up with your other work or from the table of contents on creatormath.com, that's the information, the title right there you're looking for. So here's the directions to this page. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages. Don't forget those from creatormath.com. So we're in a unit on trigonometry. This is the 4th lesson. We're going to be talking about the cosine function today. And trigonometry, I rate it as a 8 or 9 out of 10 in terms of difficulty. Students struggle because the vocabulary is completely new for them. The idea of a sine function or a cosine function or a tangent function just sounds so strange, okay? So you're going to have to kind of just learn some new words and roll with it for a while until stuff starts to look repetitive. This says, given the figure below, what's the opposite leg or op leg for the given reference angle? All right, there we go, my marker works. So notice the triangle we're given. It's a right triangle. How do I know? Because it's got a square in one corner, one of the vertexes, which is an angle. One of the angles has a square. That means this angle is exactly 90 degrees. That's what a right triangle is. A right triangle is a triangle with one 90-degree angle. Now these have to be less than 90 because the sum of the angles of a triangle are 180. So 180 minus 90 would be 90. These two have to be split between 90, so I know they're smaller than this one. That brings up the idea that this side over here, the longest side of the triangle, across from the largest angle is the hypotenuse, you guys. Hypotenuse, pronounced hypotenuse. Side C is the hypotenuse. The other sides of the triangle have names. They're called legs. So every triangle has 2 legs, like a human. And the 2 legs are attached to the largest angle, in this case the 90-degree angle. So this one's asking for the opposite leg. So it's one of these legs, and it's opposite the reference angle. The reference angle is here. It's an alpha, which is a Greek letter. Alpha is used, the Greek letters are used to represent variables for angles. So this is an angle, this is an angle, this one. This one's blank, so we don't care about it. The reference angle focuses us on this angle. Then it's asking where's the op leg for the given reference angle. So the op leg changes if the reference angle changes, but since it's here, opposite means across from in geometry. So we're going to go to the leg across from the reference angle alpha, and it's side A. So we're going to mark side A here. Just a note, my multiple choice is all lined up with the correct answer on top. Yours are going to be randomly mixed up, right? Just keep that in mind. Mine's a lot easier than yours. You've got to actually find it. All right, move to the next. Given the figure below, what is the adjacent leg or adj leg for the reference angle? So once again, focus on the reference angle. That's alpha. Focus on the 2 legs like a human attached to the largest angle. And adj or adjacent means next to. So if this is the reference angle, this is the leg next to it. Why is it not this side over here? Because this side's not a leg. It's the hypotenuse, right? So the adj leg is side B here. Given the figure below, what is the hypotenuse, or hype? I'm going to abbreviate it hype. Notice how it's spelled, hypo, ten, and use, right? H-Y-P-O is hypo, and the word ten, T-E-N, and use, U-S-E. This helps me spell it, you guys, hypotenuse, but you don't say it that way. You're going to say it smoothly, like hypotenuse, all right? And it's a strange word because it comes from 2,000 years ago, back when the Greeks were playing around with geometry and discovering all this and naming it, right? So hypotenuse is here. It's the longest side, and it's across from the largest angle, 90 degrees. Side C is the hypotenuse. Now, that's never going to change. Hypotenuse will always be that longest side. We are going to see things like the op leg and the adj leg change position depending on the reference angle location, and I'll show you that in just a minute. Given the figure below, what's the reference angle? So now they're focusing us back on this idea that the triangle in trig is always going to have a reference angle. That's the one we're interested in. This is using the Greek letter alpha. Looks like this. You know, you draw it like that. And sometimes when they draw it in the computer, they draw it tighter, like it looks like this, almost like an A, because the Greek letter alpha is an A, right? So they just want us to say alpha here. And it's just trying to warm us up to the idea that there's variables for unknown angles in a triangle, and we may name them after the Greek letters from the Greek alphabet, and alpha is A. So there's alpha, beta, gamma, right? Those kind of things for the Greek alphabet. All right, given the figure below, what's the op leg for the reference angle? Big news here is we have moved the reference angle to a different vertex of the triangle. So originally alpha was down here. We were interested in that angle, and that's the one right above it. Now we're not interested in that anymore. We have been redirected. Our focus is now directed toward the reference angle here. And now, guess what? The op leg is dependent upon this location. So we're looking for a leg. A triangle has two legs like a human, and it's attached to the largest angle. So this is a leg, this is a leg. It's one of those sides. Op means across from. It's over here, side B. Why is it not this side, you guys? You should know by now. It's because that's not a leg. That's the hypotenuse, right? It's not a leg. There are legs, two of them, like a human, and there's a hypotenuse. Those are the three sides names of a triangle. The names of the three sides of a triangle. Big news here is op leg shifts depending on where the reference angle is. They ask us where's the op leg after moving the reference angle. Now, I bet they're going to ask us where is the adj leg. All right, so given the figure below, what's the adjacent leg or adj leg for the given reference angle? Reference angle is this one. It's been moved. It's a leg, two legs, like a human, attached to the largest angle. Not that side, that's the hypotenuse, it's not a leg. Adj means next to or adjacent, right? So it's this one here. It's side A. That is the side or leg next to the reference angle, side A. Now they're trying to push us a little bit and say, hey, we moved the reference angle, but given the figure below, what is the hypotenuse or height? Well, big news here, height never changes. It doesn't matter where you put the reference angle. That hypotenuse will always be the longest side and across from the largest angle, side C. So notice they've given us the orientation of the right triangle stays the same every time. They're trying to walk us through this process and get us warmed up to trig and get us to understand some basic things before they start moving and flipping everything around, right? That's why the triangles all look the same and are oriented the same. Given the figure below, what is the reference angle? Reference angle in this case is alpha. That's all they're trying to do is get our brain to think, hey, I'm looking for a reference angle when I'm doing trig. What angle are they talking about? That's the reference angle. Here it's noted by an alpha. Notice this one's blank. We're not interested in that one at all. We're going to ignore it. All right, trigonometry, the study of angles, basically speaking, right, is what that word means. Loosely translated, trigonometry is the study of angles. There are three new functions for you: sine, cosine, and tangent. We mainly are working with 90-degree or right triangles, if you've noticed so far. Now that's a little unfair because on the last two lessons, lessons 7 and 8, we'll deal with the law of sines and the law of cosines, which deals with non-right triangles. So, but for now, think of sine, cosine, and tangent as all right triangles, and that'll serve you well for the meantime. That's what they're trying to do right here. Then they're trying to give us a method. This right here is so, ka, toa. Everybody repeat after me. SOHCAHTOA. Okay, good. So stands for sine, op leg over hype. Ka stands for cosine, adj leg over hype. Toa stands for tangent, op leg over adj leg. In other words, it's an acronym. I think I'm saying that right. An acronym is a series of letters that stands for words, right? Hope I'm saying that right. So in this case, ka is what we're interested in. This is the one, SOHCAHTOA. Repeat after me. SOHCAHTOA. SOHCAHTOA. That's what you need to remember these trig functions. Otherwise, memorizing them becomes really annoying. The definition of cosine trig function. Here we go. cosine of alpha, that looks supposed to be my alpha like that. Cosine alpha, I'm going to rewrite it in my handwriting, is by definition adjacent leg over height. Adj leg over height. Right? This is a definition. I'm going to memorize it, or I'm going to get lazy and memorize ka, so, ka, toa. And when literally I can sit down and write out so, ka, toa. And now I can remember how to define cosine right here. Cosine of the angle equals adj leg A over height. Given that definition now, let's use it to, for the following figure, what is the proper setup using the cosine trig function? I'm doing cosine, so I'm going to write cosine. Here's my definition. Alpha equals, alpha is an unknown angle, and notice they're focusing us with a question mark in this case. That's the reference angle. They didn't name it alpha, they just put a question mark there. But this one's blank, we don't care. That one we know is 90, we don't care, right? So we ignore those two, we focus on this reference angle. So when I say alpha here, I'm already thinking that angle. Then I say adj leg, that's his definition, over height according to my SOHCAHTOA. Now I'm going to fill this in. Cosine alpha equals, I have an adj leg, that's the leg adjacent or next to the reference angle, 7. There's a fraction, 7. And then over height, the hypotenuse longest side right here is 15, so that goes in the fraction like this, right? Cosine alpha equals 7 over 15. Oh, and so I marked this one right here. The next one is very interesting for us. It says for the figure below, what is the proper setup using the cosine trig function? Well, we start with the definition always. It's adj leg over height. There we go. The question here is this one, unknown, alpha. It's like saying x in algebra, right? It's a variable. We don't know what it is, but we're going to find it. Cosine alpha, I'm going to fill in the adjacent leg is here. That's a leg. Triangle has 2 legs attached to the largest angle, and it's next to means adjacent, so that's what adj leg means. It's 7 over 15 is the height, so that goes here. Now the interesting thing about this is they rearranged the problem to show us this arc cosine. The cool thing you can do with this function is you can split it up. This thing normally acts as a unit. Cosine alpha acts as a single piece, but in this case we get to separate out the angle, move the function over here, put a -1 on it, and drop this fraction in right here, 7 over 15. And just the way I drew it is the way you should get your brain to think of it. I'm going to show you how to solve for this on your calculator in about 2 minutes. But before I do, for the following figure, what is the proper setup of the cosine function again? Let's do it. Cosine alpha, this is our definition, adj leg, you're going to get it from SOHCAHTOA over height. Cosine alpha, interestingly enough, this is my reference angle because there's nothing else even referenced, right? This one's blank. They gave us the angle, folks, so there's 27 degrees. We already know alpha, but look what we don't know. We don't know this side over here called the hypotenuse. So this equals, hypotenuse on the bottom is an x, and the adj leg here is a 5. Now, algebra-wise, we can use our cross-multiply rule, and we can move over the x to here. The 5 stays on top, and now the entire cosine 27 degrees comes in here. And I'm going to show you on my calculator. It's going to be a little bit clearer when I type it into my calculator how that works. But before we do that, do one more setup. Cosine alpha equals adj leg over height. Why am I writing that? Because it says for the figure below, for the following figure, what is the proper setup using the cosine trig function? I do have 27 again, so I got cosine of 27 degrees equals, now the adj leg is x, so I'm going to put x over height is given to us as 14. And I'm going to multiply both sides by 14 here. All right, it's going to cancel 14 over 14 is 1. X is going to equal 14 times cosine 27 degrees. Okay. With that said, now let's turn to our calculators. Okay, let me clear this out. And let me go back to this. So here's my phone, right? Can we see it? Here's my phone. Here's my calculator. This is the standard app on your phone. As long as you have your rotate function unlocked, if you grab your phone, turn it horizontal, look at what happens. This whole other calculator opens up. I'm assuming you already know this exists. But look at what you've got on this calculator. You've got sine. And when I was a kid in high school, you guys, we started talking about trigonometry, and sin was on my calculator, and I was like, what the heck? Am I in church or what? I used to have to go to church when I was a kid, and we'd talk about sin, and now it's on my calculator. It stands for sine, right? And this stands for cosine, and this stands for tangent, the three trig functions we're going to deal with. And here, first things first, make sure you're in degree mode. See this radian? Radian showed up here. We do not want radian mode. We want degree, so click it again. When nothing's there, it's in degree mode. Then let's put this where we can possibly see a few things at the same time. Maybe I can go a little bit higher on this. How about that? Okay, that's kind of okay. So what I want to show you is here. Here we've got this 14 times the cosine of 27. Right? Let's switch to the calculator, and let's say 14 times, and then notice the trig function here, cosine, look at that, how cool. And then we said 27 degrees, 27, and I'm going to finish it off with a parentheses just so it kind of looks like my setup, right? If I had a parentheses right here, then it would look a lot like that. 12.47. So I'm going to say x is approximately equal to 12.47. Why approximately equal? Because I can't say equal anymore, because I would have to write out all these digits to make it equal. And I can't. They go on and on forever. They're irrational number-ish kind of thing. I'm not totally sure this is an irrational number. I think it is. So anyway, you're truncating these digits, which means you have to go to 12.47. You have to say it's approximately equal and use a waving flag equals to show approximately equal, right? With that said, move to the top one. Let's plug this one into the calculator too. Here we have x, and I'm going to write over top of stuff, is approximately equal to, let's clear this out. We're going to say 5 divided by cosine of 27 in this case. 5 divided by cosine 27 parentheses. See the divided by symbol? 5.61. And to kind of show what we got here, x is 12.47. That's the length of this leg. So if this is 14 and it's the longest side, it's the hypotenuse, this being 12.47 long, that pretty much makes sense to me. Up here we're finding actually the hypotenuse we solved for, right? That was where we put the x, was for the hypotenuse. This is 5.61 long, and that's longer than 5 here, so that makes sense. I'm okay with that. I'm okay with that. They pretty much look, I don't know exactly right, but that looks pretty good to me. Let's go back one more. I want to show you the arc cosine calculation. And let's do this. Here we wrote up alpha and we did a cosine to the -1. We're going to find the reverse of this. You know how we learned multiplication, that was one direction, and then we learned division to go backwards? This function, math is like this. There's a forward and a reverse. Cosine is forward, cosine to the -1 is reverse. Students often mix it up with a power to the -1, but if you had x to the -1, that would mean 1 over x, and that's a totally different situation, so just ignore that. Just think of forward cosine and reverse cosine, called arc cosine or a cosine. And watch my calculator. This part I think is so cool. If you do second, there's a whole nother keypad here, and notice it's sine to the -1, cosine to the -1, and tangent to the -1. It's the arc functions over here. So what we're going to do is clear this out. Let me clear. We're going to put in the arc cosine of 7 over 15. So here's arc cosine, and they put in a for that. A cosine is arc cosine or cosine to the -1. And let's put 7 divided by 15 and parentheses. All right, I get 62.18. So alpha, and alpha represents an angle, is approximately equal to 62.18. That's the measure of this angle right here. The angle measure is 62.18 degrees, right? So I don't know if you can kind of see the big picture, but what's happening here is trig allows us to solve using these different trig functions and given sides, and now we have a sine and a cosine. We can use side lengths to solve for a missing angle. We can use an angle to solve for a missing side length. So what we have here is sort of an incredible tool for solving right triangles, and we love it because it's such a cool system that works for every single right triangle. So find this information on creatormath.com and match it up with the assignment you got to do, and I hope it helps.